can you make a decision with a certain amount of information and be comfortable with the risk and be able to adapt when the situation ultimately changes?
Right. Yep.
And in business, right? I mean, you can have a strategy. Right now, today, we were working on our 2026 strategic initiatives. I think that's the direction we need to go, based on things that we're doing now, based on recent projects and opportunities that we have, based on where I think the market's going, based on where I think the technological needs are, and where our technology could have an impact. 2026 may roll around and the situation changes fundamentally.
Welcome to Manufacturing Insiders. Today I have Jason Riley with me. He is the CEO of Fabrisonic. He has a PhD. He is a Marine like myself. He was a Marine officer for 20 years. He's in the reserves now, served in multiple theaters. He's also a writer, which I came across recently. He wrote a book or co-wrote a book called Left of Bang, which I'm very interested to hear about. I just kind of read a brief snippet, but the concept that I briefly read about was kind of using your gut to predict, bad situations, and applying that in business as well as in the military, which that's obviously a key characteristic when you're kicking down doors and in combat situations. But welcome to Manufacturing Insiders, Jason. Excited to have this conversation.
Yeah, thank you so much for having me.
Absolutely. Before I get too far into it, just like to mention, please subscribe to the podcast. Give this a like. We're on YouTube, LinkedIn, Instagram, pretty much anywhere you can look. Share this, listen to it on your way to work. If you're a manufacturer and you're a leader who has some insights that could benefit other leaders, please go to manufacturinginsiders.com, fill out the form there, and we'd love to have you on. So Jason, let's start with your background in the Marine Corps, and just tell me a little bit about kind of what some of the things that you've done, some of the positions that you've held there.
Yeah, so I'm an infantry officer by trade. And the Marines will know, the MOS 0302. Got commissioned in 2003 after being a part of the Ohio State ROTC program, the Marine option. Went to OCS and then the basic school. And at the basic school, kind of fell in love with field craft stuff. So being out in the field patrolling, those kind of things.
Yep.
And, did well enough that I could kind of choose what MOS I wanted. Chose infantry, went to infantry officer course, and then after that joined 1st Battalion, 2nd Marines, which is an infantry battalion in Camp Lejeune, North Carolina. Spent 3.5 years or so, whatever my initial contract was, stationed there, but mostly deployed. So did the 24th Marine Expeditionary Unit deployment to Iraq from 2004 to 2005. Came back. We were then pretty early on after getting back, assigned to the 22nd Marine Expeditionary Unit, which was an actual, ship deployment. So we were on ships floating across the Atlantic to the Mediterranean. Then, as it would happen, got off the ships, went back into Iraq for, about 90 days or 120 days or something like that. And then, floated back. Then the third deployment on active duty that I had was to Afghanistan as an advisor to the Afghan National Army. That was 2006, 2007. And then got off active duty, spent a few years doing a master's program. And so I was a platoon commander for a few years, and then did a short stint as a headquarters and service company executive officer and the commanding officer for a little bit. And then did the Afghan deployment as an advisor. Like I said, did a couple of years in a master's program, then took the opportunity to go back on active duty mobilization orders to Camp Pendleton, California, to serve at the School of Infantry, which is there. There I was a part of what's called the Combat Hunter Program, or what's called the Combat Hunter Program. So I was a team leader for a team of instructors that trained a variety of Marine Corps units, mostly on the West Coast, Hawaii, Okinawa, those kind of things. And then have spent the rest of my career in the reserve component. Was a battalion operations officer, weapons company commander, and then battalion commander, and served at a few other places in between there, regimental executive officer, and then my current role is with the Marine Corps Warfighting Laboratory.
Gotcha. Okay. Wow. Yeah. I mean, that's a huge amount of experience there. We definitely had some crossover in some of the things that we did. I was also an advisor to the Iraqi Army in my
Yeah.
time,
Yep.
and spent a little bit of time in Lejeune, spent some time at Pendleton, spent some time in 29 Palms. You know, all the fun places. But no, that's awesome. And I want to get into you know, some of the applications and leadership in the Marine Corps to the business world. But before that, I do want to mention that one of the topics we're going to cover today is in the additive manufacturing space, and it's more specifically ultrasonic additive manufacturing, which is a relatively unknown process or not well-known process in the manufacturing field. It's going to have a ton of application in the future. Obviously, we know the way things are going with additive, but with this specific process, you can do a lot of things that you cannot do with other manufacturing processes. So just want to kind of put that teaser out there before anyone loses interest. We love talking about the Marine Corps, obviously being in the military, but some of the leadership traits and in lessons that you learn in the military, especially being an officer, have facilitated and brought Jason to this position. He's in the CEO position, really with, 10 years ago, having no knowledge whatsoever of this type of manufacturing. So I think it's very interesting. So let's jump into that first. When you look at your position, your role as CEO in Fabrisonic, what do you point to in your military experience that has brought you here?
Yeah, so I'll just make one small correction. So I'm now general manager. We were acquired in March by a company called United Performance Metals.
Okay.
And so I took over as CEO last September when the former CEO retired. So I say that I was promoted by attrition, demoted by acquisition. So
Okay, gotcha.
Yeah, no worries. So what was the question? Sorry.
So with all of the experiences that you've had in the Marine Corps, all the courses that you've gone to, obviously OCS and all of that, what do you really attribute your success in the business world to as it relates to that experience?
Yeah, I mean, other than luck and just being in the right place at the right time, I think a few things stand out. One, we talked in the Marine Corps about bias for action and taking advantage of opportunities that are presented,
Yep.
To do things. And so I think that's one, just taking advantage of opportunities and showing initiative and having initiative to try different things. I think a tolerance for risk
Yep.
is another important one.
Yep.
Decision making, communication, all of those things. And then I think just, general, leadership principles. I mean, really having been some of the best leadership courses and training and having some of the best leadership experiences, I've benefited from serving under some really great, humble, exceptional, commanding officers and officers in charge and things like that, who I've been able to learn from and emulate. So that's been one of the things. Having a career where people are intentionally building into you, intentionally correcting you, intentionally evaluating you, having that constant, now 20 plus years of feedback on, hey, here's things you're doing well, here's things you're not doing well, here's things you need to get better at. I think that's invaluable.
Yep. Which I agree
I
with
think
that
decision
completely.
making.
Yeah,
Go ahead.
That's one thing that really stands out to me from my military experience. In fact, I remember to this day, and we're talking 20 years ago now. Like after I got done with the School of Infantry, I had one sergeant tell me, he's like, Nate or Wheeler, I think you could be a really good leader. You're smart. You know what you're doing. You do a great job with everything, but you just don't take initiative to take those leadership positions, which that was kind of my mind. I was kind of like, I don't, you learn in the military, don't volunteer for anything, right? All you're going to do is get shit on if you get in that squad leader position or whatever. But no, those little evaluation moments stand out to you, and you remember them for a lifetime, and they really feed into building you up as you grow. So I think that's a really
Yeah.
important one.
Yeah, I would share a similar story. When I was a young platoon commander, and I can't say that I was exceptional. I did an all right job probably. But I had a first sergeant have a very difficult conversation with me that, I wish I could contact him now and thank him for it. But, it was very similar. Like, hey, you're not, you're not doing what you need to be doing. Right. And so having people that are courageous enough and have a position to be able to tell you that and give you that feedback, has positively affected my career since then.
Right.
Um, but I think a few other things that stand out. One, decision making. I think, that's a thing. And you mentioned the book Left at Bang that I co-wrote, and a large part was about making decisions. It's a human, it's a human universal. We have to make thousands and thousands of decisions each day.
Right.
Rarely are we taught a method of making decisions, right?
Right.
From kindergarten all the way through graduate school, I never had one class or formal piece of, education, except for in the Marine Corps, about making decisions under pressure, making decisions without all the information you need. And those are the kind of decisions we have to make on a daily basis. You never have all the information that you need, whether it's a business decision or a decision about your family or life. Um, and so just being able to kind of quickly take a look at something, dress it down to the most key important aspects, and then being, willing to make a decision, even in spite of the risk involved in making that decision,
Right.
I think has been helpful. So I think there's so many. I mean, I can go on for, we could have a whole podcast just about what the Marine Corps has taught me
Yeah.
and helped me to do in life. I mean, really, I owe a huge, debt of gratitude to my service in the Marine Corps and the people that I've served with and people that I've learned from.
Right. Yeah, and honestly, I like what you said about, making the decision without all the available information, and also understanding that there's risk involved in making the wrong decision, but making it anyways. But that kind of goes back to that bias for action. And I almost have that spidey sense too, where it's like, I don't really want to make a decision right now, but I fear the consequences of not making a decision. And I think
Right.
that's a
Yeah.
really important leadership characteristic, in that if you just sit back and let things happen, it's probably not going to go your way. You're better off making a mediocre decision right now than a perfect
Yep.
decision later.
Yeah. Yeah. And I think you highlighted it. Not making a decision is a decision,
Right.
right? It's just a decision that you can, there's a little bit of you know, not doing something allows you to blame the situation,
Right.
right? Well, yeah, I didn't make a decision, but the situation is what, ultimately caused this catastrophic consequence or whatever. There's some plausible deniability if you don't do something, right? I
Right.
mean, I think we see this in bureaucracies and administrations and things all the time where, a hard decision has to be made. They'd rather do nothing than something, because
Mhm.
if they do something, then they're to blame. But if they do
Right.
nothing, well, they can just blame the situation. But I think, early on, as you experienced, we do these in the Marine Corps, these tactical decision games. And I remember, the key phrase is what now, Lieutenant? You're faced with a situation. What are you going to do? And it's not, there's no option of not doing something.
Right.
You need to make a decision. And I remember this one very specific tactical decision game at the basic school or infantry officer course where, they deliberately allow you to leave the room whenever you want to. At the end of the, however long, 15, 30 minutes or whatever, of the game, you have to come back with a presented solution. And they over time slowly give you more and more information. And some people stay all the way to the very end because they think that there's going to be some piece of information that's going to be the key to solving the problem, right?
Right. Right.
And that's never the case. Some people leave the room right away. They see the picture, they intuitively think they have an answer. Some people stay a little longer. But you have to choose at some
Hmm.
point when you're going to leave the room and then write down your solution.
Right.
And there's no right answer. That's the thing. There's no right answer. It's okay. At what point do you believe you have enough information to go and make a coherent decision. And
Right.
there's this, like you've just said, there's this risk, there's a scale of risk, right? Balancing, how much information you have with how much risk there is in potentially being wrong. But at some point, you just got to get comfortable with being okay making a wrong decision.
Right. So
Um,
with that,
you
when they
know,
evaluated it, what did they say to you? Was it the people who left immediately and had a gut feeling about it were the kind of winners of that, or were people that just waited a little bit longer? Like, what? How did that work out?
yeah, so I would boil it down into kind of a couple principles. One we've already discussed. You're never going to have all the information you need.
Right.
Two, there's rarely ever going to be the one single piece of information that's like going to untie the Gordian knot, right? That's going to be that key of this is the answer.
Hmm.
And I think some people, want to believe that's why they stay the whole time, right? They believe that there's going to be one piece of information that they're given that's going to tell them what the best solution is.
Right.
Um, so it's really about making a decision. It's really about making a responsible decision based on the information you have. But then more than that, the situation is always going to change, right? We have this another phrase in the Marine Corps, right? The enemy gets a vote. Um, in business, the economy gets a vote. Your competitors get a vote. So it's not about necessarily what did you make the best decision. Is did you make a decision and then adapt when the situation changes?
Right.
So I think that's what that tactical decision game really is about. It's like, hey, you need time to plan, you need time to prepare, you need time to put your decision into words, right? We would call that an operations order or tactical order or something like that. You need time to communicate your plan to your team. They need time to plan and prepare, communicate to their Marines what's going to happen. So you have to take into consideration that, like, if you take all the time to plan and your team doesn't have time to do what they need to do, well, you might have the best decision, but you're not going to execute it very well.
Right.
Additionally, yeah, once you hit the ground, the situation may be totally different than what you thought, right? The information you have might not be the most available information, might not be the best information.
Right.
So you have to be able to adapt and adjust and make different decisions after that. So it's really a starting point. I mean, there's all these great phrases and sayings, right? Like, failing to plan is planning to fail, or like you just, you said a few yourself. So it's really just about, you know, can you make a decision with a certain amount of information and be comfortable with the risk and be able to adapt when the
Yep.
situation ultimately changes?
Right. Yep.
And in business, right? I mean, you can have a strategy. Right now, today, we were working on our 2026 strategic initiatives. I think that's the direction we need to go, based on things that we're doing now, based on recent projects and opportunities that we have, based on where I think the market's going, based on where I think the technological needs are, and where our technology could have an impact.
Hmm.
2026 may roll around and the situation changes fundamentally. A new technology develops, a new need is discovered, a new opportunity arises that
Yep.
tells us, hey, we should go in this direction and not the strategic plan that we had. Now, some companies might establish a strategic direction, and regardless of what happens, they're not moving, they're not budging. That might be the right call, and so that's where leadership comes into play.
Yep. Yep. Yeah, I agree completely. And that's one of the deficiencies I see in the manufacturing space. I talk to manufacturers every day, have a lot of manufacturing customers, and I feel like a lot of them are frozen in that inaction space because there's so much going on. There's so much new technology. There's AI. There's additive manufacturing. There's all these new pieces of equipment you could buy, and they're like, well, we're just going to keep doing what we've always been doing. And that may work for a little while, but I've been kind of aggressively preaching the message that I don't think it's going to. I think that you have a very limited time span if you're doing the same thing. You're not figuring out how to integrate AI, automation, and bringing some new technology into your facility. So I really kind of want to get that message out, what we're talking about, that we need to take action. We need to, even if it's not a perfect decision, make a decision, start moving towards technology, because otherwise we're not going to be able to compete.
Yep.
China's already way far ahead of us in terms of AI and technology.
Yeah. Yeah. And to caveat on that, so last week I had the opportunity to go to the sales council meeting for O'Neill Industries. So I mentioned that we were purchased by United Performance Metals in March. UPM is a subsidiary of a much larger company called O'Neill Industries.
Okay.
O'Neill Industries is a 104-year-old privately held family-owned company that started out as O'Neill Steel. And in the past 104 years has grown, has acquired other companies. Now most of their companies are in the bulk metals distribution and production industries. But over time, they've acquired or even invested in and started other advanced manufacturing and advanced solutions companies, right? So they have a company in their portfolio called StellaSource, which is a front end, sales platform to purchase metals from, a variety of metals companies. They have us, which is a very, very unique niche manufacturing capability. They have United Performance Advanced Solutions, United Performance Metals Advanced Solutions, which is in the additive manufacturing servicing industry.
Okay.
So it's a company that, kind of what you're talking about, has a core product, has a core set of products that they've been doing for now 100 years, but is not afraid to take a risk and either start or purchase or acquire or build companies that are in new metals technologies.
Yep.
So that's our, kind of, I would point that out as an example of a company that is willing to take risks and go in different directions and question, the status quo.
Yep. Yeah. And at least a method of diversification, because obviously commodities are always going to be commodities and be necessary. But yeah, diversifying into some different types of technology is very smart. So can you give us just kind of the elevator pitch for your technology at Fabrisonic, kind of where it stands in the world of additive manufacturing and what the unique benefits of it are?
Yeah, absolutely. So ultrasonic additive manufacturing, or UAM, is a novel manufacturing approach, but it's a novel in the sense that it combines some pretty traditional manufacturing technologies. At the core of our technology is what's called ultrasonic welding. Ultrasonic welding has been around for 60 plus years. I think the first patent was like in the 1950s. It was initially commercialized, I believe, in the plastic toy industry to weld plastic toy seams together.
Okay.
And then from there, it expanded into other, metal manufacturing processes, wire bonding, seam welding, spot welding. It's in the automotive industry. It's in the battery connections industry. It's in a wide variety of other industries. So it's pretty standard, manufacturing technology. Our ultrasonic welding systems are very unique. I think we have like the most powerful ultrasonic seam welder in existence. But our ultrasonic welding systems are integrated into CNC machines. So we have a truly hybrid manufacturing process. We can add material and we can subtract material. A couple things that make us different. When most people think about additive manufacturing in the plastics, they think about like polymer, filament. In the metals industry, they probably think of powder, right? So laser powder bed fusion, where you're taking a laser, you have a thin layer of powder, you're taking the laser and you're melting the powder and you're making these organic innate geometries or whatever. Our form factor is thin sheets of metal foil. And so we have an ultrasonic tool that comes down. It's a rolling sonotrode, so it rolls over the material, bonding the foil to the substrate. And the process that happens is ultrasonic welding. And so ultrasonic welding, the way it works is you have this acoustically tuned piece of metal. It scrubs side to side on the foil or on the material. That energy, that scrubbing energy, and ours scrubs at 20 kilohertz, so 20,000 times a second, is transferred through the material to the interface of the material you want to bond, the foil, to the material you want to bond to, the substrate. And what happens is that scrubbing effect shears off the oxide layer between the materials, causes some plastic deformation, and through the combination of those forces, you get a solid state metallurgical bond. So it's,
Hmm.
in some sense, it's very similar to like a friction weld or something like that. And so we just kind of do that over and over again until we bond the sheet of metal foil or a piece of slip metal tape to the substrate. And then we just keep building up layer by layer by layer in Z until we get to the height that we want to build to.
Right.
And then we come in with the CNC mill and we remove material to create the three-dimensional geometry. Now, what are some things that make our process stand out from other manufacturing methods? One, it's a low temperature process. So laser powder bed fusion is a fusion based process. You're melting the materials. TIG
Okay.
welding, MIG welding, those kind of things are fusion based, manufacturing methods to join one metal to another. Our process is a hybrid process that's low temperature, so we're not melting the material to join them.
Right.
Um, some of the things that allows are we can pretty easily join different metals together and not get the unwanted intermetallics or the kind of diffusion you get when you do a fusion-based welding process.
Okay.
So we can join copper to aluminum fairly easily. We do that probably every day for a variety of applications. That's something that you can't generally do with other manufacturing processes. Um, a similar process would be like brazing, but brazing requires a brazing foil. We don't need that. We can actually get direct metal to metal contact between the two materials that we want to bond together. Other things that our process enables is we can embed sensors into fully dense metal parts, thermocouples, fiber optics, strain gauges, those kind of things. And that allows people to get direct feedback and data from inside of a component, maybe closer to where they actually want to, capture the data from or collect the data from. And then another application, which is a really high importance to us, is the ability to make internal geometries. Most of the time, that translates into something like a fluid transfer device or a heat exchanger
Hmm.
for thermal management.
Okay.
Um, yeah, so that'd be kind of like I guess that was about a 2-minute
No.
introduction to the technology. But
Yeah, that makes a long elevator ride, but no, it's good. Um, so with the heat exchangers, the benefit here is that you don't have a say unwanted bonding agent between the layers, which allows you to have better conductivity inside of that
yeah,
heat exchanger.
yep, yeah. So the way we pitch this is, um, if you're bonding dissimilar. So okay, so let me back up a little bit. Heat exchangers, right, is all about thermal conductivity, right? Getting heat out of one thing, right, and cooling it down.
Right.
Um, and this is the problem of the now and the future. The more powerful electronic components become, semiconductors, microchips, things like that, the more heat they're going to generate. An NVIDIA chip, right, a brand new one is, let's say, $30,000 to $40,000. That thing overheats, right, and is damaged, right. That's $30,000 to $40,000 out the window.
Right.
So you have to cool these things down, and there's a lot of novel technologies being developed. But that's just an example of a thing that needs to get cooled down. Everything that generates heat has to get cooled down. Your car engine, right, has a heat exchanger. It's called a radiator.
Mm-hmm.
Fluid's going through that, air is going across it, and because of convection, it's cooling that fluid down. It's going back into your engine to cool those components down, and that loop continues continuously. There's other types of all over the place. There's heat exchangers. And so, the benefit of ultrasonic additive manufacturing is, one, we can join dissimilar metals together, right? For space and aerospace applications, weight is an important, aspect.
Mm-hmm.
And so we can make something mostly out of aluminum and then add some copper into it, which has twice the conductivity of aluminum, get the benefits of the copper's thermal conductivity, but have the lightweight, aspects of aluminum.
Right.
When we join two metals together like copper aluminum, uh, as opposed to brazing or diffusion bonding or some other method of joining two different metals, those have a fairly large intermetallic growth that occurs between, because of the high temperatures that they do brazing and diffusion bonding at. Like I said, we're doing it at a very low temperature, so that intermetallic growth is extremely small.
Right.
The thicker the intermetallics, the higher the resistance, right? And so you're going to have just lower thermal transfer between the two materials that you're trying to join together.
Right.
So we would have a much better conductivity, a much lower resistance at that interface.
Right.
And when you're trying to cool down extremely, costly and highly sensitive electronic components like that could make. So that's one way in which, UAM has a benefit over other manufacturing processes in heat exchanger devices. We can also do just very interesting geometries inside of a heat exchanger that you wouldn't be able to do through a normal manufacturing process.
Right. Yeah, and you can kind of get those near net shapes, so that way you aren't machining off a whole bunch of material at
Yep.
the end, right?
Yep. Yeah, exactly. Additionally, our parts don't generally need other post processing. With a laser powder bed part, you might need heat treating and hipping and things like that. Our parts generally don't need that kind of post processing. Additionally, because we're milling the channels, we get that mill surface finish inside of the channels, which if you're doing laser powder bed, you're not going to be able to get that same quality of surface finish
Yep.
interior to the part. And so you have less, back pressure and those kind of things. There's no concern about, powder being still inside of the component. Um, or, uh, again, there's a lot of differences between a part that we make and a part that laser powder bed would make. But, making a part out of UAM has a number of benefits that we think, increase the performance and decrease the risk of making a component out of, an additive manufacturing process.
Right. Right. So when you're so I mean, say you end up joining, with foil layers, 1/4 inch of aluminum to 1/4 inch of copper. Is there any risk, like let's say it was a fluid channel, that with the pressure buildup in there, say it's a high pressure system, that would separate again into sheets? Like, how strong is that bond?
Yeah, the bond is pretty strong. I mean, we've tested parts up to several thousand psi. Any heat exchanger device that we make, we do pressure and leak testing on it.
Mm-hmm.
And so we've achieved helium leak rates to E to the -9. We've achieved burst pressure rates, like I said, up to several thousand psi.
Wow.
Obviously, depending on a lot of factors, the geometry and how many layers are we welding and those kind of things. But generally, the types of pressures that you're putting into, a heat exchanger are well within the
Right.
capability and the bond strength of UAM.
Right. Right. What big players, maybe in the heat exchanger industry, have been pretty receptive to this technology?
Yeah, so a lot of times we're working with the R&D components of, let's say, tier one aerospace companies, space companies. We're working on some projects now for heat exchangers for satellites, or like I said, aerospace applications. I mean, again, the challenge is heat, right? Heat rejection, uh, and just thermal management of high performance electronics.
Right.
And there's no one industry, that needs that.
Right.
Automotive, electric vehicles, data processing, aerospace and space, um, nuclear. There's a wide variety of industries that our technology is applicable to.
Right. When you see an application that you think is perfect for your technology, what are some of the challenges or pushback that you've got from some of those OEMs?
Yeah, I mean, you know, a lot of companies, especially if they're well-established companies, um, they have a conservative approach, right? They have a technology that they know works.
Yep.
And so anytime you're trying to pitch a new material, a new manufacturing technology, right, the question is always, what's the data? right? Show me that, your technology, like you just asked, right? Is it going to survive the pressures that a heat exchanger uh, might experience? What is actually the thermal conductivity of this part?
Mm-hmm.
Those kind of questions. And so it's always it's very much a development project initially. Hey, let's do a small scale development prototype,
Yep.
test that, make sure that that hits all of our criteria, and then we go from there.
Yep. So, what has been your strategy to get in front of some of these companies? Are you going to trade shows? Like, are you educating engineers in large groups? Like, how are you going about it?
Yeah, so we have a number of approaches. In fact, as I mentioned, we're working on our 2026 strategy now. And that's always the question, right? Is how does a small company like us get the awareness that we need to generate leads and opportunities?
Yep.
Being a part of a larger company now, I think we benefit from their marketing and business development and stuff like that. But the challenge is still the same. So we do a lot of trade shows. So we might not necessarily exhibit at a lot of trade shows, but we walk a lot of trade shows.
Yep.
And anybody that's at a electric vehicle trade show or a thermal management trade show that's exhibiting is a potential customer for us.
Sure.
Because they're selling a product, which again is going to be in one of those focus areas for our technology. So we'll do a lot of that. Obviously we have the website, and so we try to manage our website and create it so that it does have that search engine optimization, the keywords and those kind of things. So we do get a lot of hits for people just Googling random stuff like dissimilar metal heat exchangers.
Mm-hmm.
We'll publish white papers, or we'll publish in some industry magazines based on recent projects that we've done that we can share publicly. And, things like this, podcasts, social media presence, those kind of things. And then also, in a large part, word of mouth. We work with some really large companies. Those companies talk about internally technologies that they're using that might be of benefit to other divisions or research arms within the organization. And then you mentioned one that we have actually done as well is we'll do these lunch and learns, or we'll do on-site workshops for potential customers or customers. And so we'll go there for a day or an hour or however long they have, and bring people in and do an introductory workshop. What is UAM? How does it work? What are the applications? And we find that that is very beneficial because it gets our manufacturing technology into the minds of the engineers. We may not solve a problem there. We may not identify a very specific application during that one meeting, but we get them thinking about UAM as a potential solution for solving problems. And nearly every single time that we've done one of these lunch and learns or workshops at a customer's location, it's generated in a purchase order. So that's been a very, very beneficial technique for us to get in front of customers.
Yeah, I mean, I think that's a great strategy. I've talked to quite a few companies that have sort of a new process, a new product that they're bringing to market. And the big challenge everybody runs into is you need to somehow get these engineers to allow for some flexibility in the manufacturing process, before you're ever going to be able to apply what is going to work to that company. And that's the big challenge is like, how do you do that on a broad scale? When you do it in a lunch and learn, yes, you can address, 15, 20 engineers, but there's potentially, hundreds of thousands of them that we need to get in front of. It'd be interesting if there was a broader way to do that. And I guess my idea is, kind of what you're doing with the white papers. Like, think about the problems these engineers are having and just start writing, anticipating what they're going to search for when they're Googling around, getting the content in front of them, making videos about it, things like that.
Yeah, yep, exactly. And speaking at trade shows and conferences and those kind of things help. Those are, often, opportunities to get in front of a wide variety of engineers from different companies and different industries.
Yeah.
And I think the key thing there is to make whatever your talk is going to be interesting, right? And applicable. You and I probably have sat through a number of presentations and conference presentations and things like that where you're like, what are we talking about? Why is this important? Yeah, I'm sure you had a lot of fun doing that research, but I'm not sure what the application is here.
Right.
So making it relevant
Right.
to the audience is obviously, I mean, that's the goal of all marketing, right? Making whatever you're doing relevant to whoever you're trying to pitch it to.
Yep. Exactly. Yeah, and I do see a lot of companies kind of make that mistake on their websites too. Is you have your own internal terminology for what you do, and you understand it well, but framing it in a way that your target market understands is a completely different story, and definitely a big takeaway. So what's in the future for you? Are you going to get back up to that? You shooting for that CEO position again, or are you happy with where you're at? Are you happy in the industry? Like what's next for you?
Yeah, good question. I mean, uh, I'm enjoying running Fabrisonic. I mean, it's a great company. We have a great team. We have a great culture here. I work with a team of fantastic engineers who, are extremely adaptive, and come up with some creative solutions, and have a lot of fun working with the kind of companies that we work for. We have a lot of engineers that have, recently graduated from Ohio State. They were interns here and then joined the company. I think it says something, that they want to stick around and want to be a part of the team.
Yep.
But it's also a very novel type of role for a young engineer, where they could easily go to a large company, a large aerospace company or something like that. And then they would probably for the first several years be doing the same thing
Mm-hmm.
over and over.
Yep.
I know people who, specialized in FEA, and they worked for, let's say, JPL or NASA or something like that. And every day they do the same. They do FEA. Someone brings them a model, tells them what to simulate,
Yep.
and what to look for, and that's what they do. Our engineers get a chance to early on. They're doing design, they're doing manufacturing, they're doing testing, they're doing customer engagement, they're at trade shows, they're doing customer site visits. I mean, every day is something different. And because of the nature of the work we do, every every day on each machine, there's some new project. And so they get to see a wide variety of things. Um, and ultimately see it end up in the customer's hands and the customer test it. So that's one of the things that I really enjoy is, you know, leading a team of engineers and just having a wide variety of experiences that they get to develop, or that develop them. Yeah, so I'm enjoying the ride here at Fabrisonic, and now being a part of, like I said, the larger United Performance Metals and O'Neill Industries family of companies is a fantastic opportunity.
Yeah, I can imagine I would imagine that having kind of those, I guess, deep pockets would definitely project the growth forward and allow you guys to get where you're trying to go a little bit faster. Maybe make some connections with some of the bigger OEMs that you might have struggled with before. But no, on the engineer side, that makes a ton of sense. I mean, I can see, and I have friends that are engineers that work for Boeing and places like that, and they do kind of get in this repetitive process where you're just given this one thing and you do it because your title is engineer, and rinse and repeat. Whereas being able to actually be involved in the development process and engage your mind and come up with new strategies would be very exciting.
Yeah, and just the wide swath of customers that we have, from the electric vehicle industry to the nuclear industry to the aerospace industry, satellite companies. They just get to touch tons of different, you know, uh, companies and different industries with different applications, and so it creates a very uh, positive sense of just diversity in
Mm-hmm.
their background. I mean, they're learning heat exchangers and how they work. They're learning electrification and conductivity and things like that. They're learning, we had a project bonding platinum to brass. And also just a wide variety of materials, that they get a chance to work with. I've interviewed a number of engineers from other companies for positions here at Fabrisonic, and one of the questions is, okay, what metals have you worked with? And they could be in the industry for 10 or 15 years and only have worked with one or two different metals in their
Right.
entire career.
Right.
So these guys get to learn a lot about just metallurgy
Yeah.
in general. And yeah.
Yeah, that's awesome. Is there anything that you've been personally looking for in terms of resources, partnerships? It could be, you're looking for more employees or some type of consulting or anything like that that you've been kind of keeping your eye out for, that if somebody's listening, they may be able to help you out.
Yeah, good question. Awareness, that's key. I mentioned that already, right? And so, you know, what uh, what are the ways in which other similar small companies have generated the awareness? And one of the things that came up today in our conversation was it's no longer uh, it's no longer um, all right just to work on search engine optimization. It's no longer sufficient because a lot of people aren't using Google,
Right.
right? And Google alone
Yep.
and keywords and things like that. Now they're often relying on these AI platforms.
Yep.
So how do you attract the attention of the AI platforms? And what are the things that AI platforms are looking for? When you say,
Yep.
give me a list of the top 5 companies that produce high performance heat exchangers, and you type that into Chat GPT or whatever AI platform that you're using, how do you posture yourself? What do you need to have out there in the digital marketplace
Yep.
so that Chat GPT, that AI software picks you up and puts you on that list?
Yep.
So I think that would be one of the biggest ones. And then also, there's so many trade shows out there, right? How do you select, where do you put your resources? That's always a question for every company, right? There's 150 trade shows out there that could be relevant. Which 10 do you go to, or 10 or 15 do you go to throughout the year?
Yep.
So how do you figure that out? And then, industry contacts, other small businesses. I'm a believer that, the right companies partner together and make huge impacts and not necessarily compete with one another.
Yep.
So what are those smaller cohorts or collaborations of manufacturing companies targeting things like thermal management and electrification and space and aerospace? Where are those CEOs getting together and having those conversations
Yep.
so that they can attack important problems together and provide a solution that is competitive with the larger companies that are out there that have the huge marketing budgets and have those deep pockets. So I think those would be
Yep.
three
Yep.
things that I would highlight.
No, those are very good. Yeah, and on the note of kind of the collaboration with similar types of companies, it makes sense that you would have a group of these companies that could kind of pull their resources together and then get a large group of engineers together and say, here are the top 10 technologies you need to know about in 2025, and kind of get that all done at once. No, that makes a lot of sense. No, great talk today. I think if someone's to take anything away from this conversation, obviously, the ultrasonic additive manufacturing as a new process to the market is, something everyone should know about. But then I really liked what we were talking about, just having that bias for action, having that tolerance for risk, and then also having those mechanisms for evaluation in your companies. I think a lot of us don't take the evaluation process as seriously as we should and make it as structured and regimented as we should. But you never know when that kind of positive or sometimes, instructive word to an employee can make a huge difference for the rest of their life. So all great lessons. Jason, thanks a lot for joining today. Really enjoyed our talk.
Yeah, Nate, thank you so much for the opportunity.
Absolutely.